Welcome students to week 7. This week we're going to be covering chapter 9. There's another homework 7 due this week. Lab 7 covers specific heat capacities, and discussion 6 is about electricity and magnetism. This chapter, it's very important to read the book. There's no additional supplemental notes, so you're going to have to refer to electricity from last week for some of the homework. The important concepts covered in the book are magnetic poles, that like poles repel, opposites attract, magnetic fields, magnetic domains, electric currents and magnetic fields. Magnetic forces on moving targets are given as F equals the charge times velocity times the strength of the magnetic field. Electromagnetic induction is covered with Faraday's law. Generators and alternating currents, power production, and I'm going to be covering transformers, boosting or lowering your voltage here in a second. And they cover field induction, which is a combination of Maxwell and Faraday. For transformers, there's a couple of equations that are important on page 222 and 223. And these are, the voltage in, which they are showing as the primary voltage. Okay, we can show that as V1 over the number of turns equals the voltage going out times the number of turns on the outward side. All right, these will be very important. These are for transformers, when you're stepping up or stepping down voltage. Then there's also the conservation of power, basically, that power in equals power out. Okay, and so that can be the same as before with P1 equals P2. And so you can use voltage times current for power, right? That we know that from previous chapters. So you can, this same equation can also be V times I, and these are both 1 equals V times I 2. All right, and we'll show how to use these. Let's look at number 3 on page 228. A transformer for a laptop computer converts a 120 volt input to a 24 volt output. Show that the primary coil has 5 times as many turns as the secondary coil has. So what we're going to do is use the same equation from before that I listed, where the V1 over the number of turns equals V2 times the number of turns for that side. So this is our in and this is our out. So we are given for the in that we have 120 volts. Okay, so 120 volts we know. And then we're going to have 24 volts going out. And so they want us to know how many turns the primary coil has compared to the secondary coil. So if we say the secondary coil is 1, then we can find out how many times the primary coil is over the secondary, okay? So we're just saying this is 1, and we're going to find this value here, okay? So then you solve normally. You have just 24 on this side and 120 on this side. So you end up with 24 volts times X equals 120 volts. So what I did, I just multiplied X onto that side. And then you can divide. So you have X equals 120 volts over 24 volts. And that equals 5, and we know these are just 5 times. So the answer is 5 times as many turns as the secondary coil has. And so you can actually go back and see how we're correct in this, that 120 over 5 is the same as 24 over 1. So number 7 in the homework is very similar to the example I just did. And for number 6, it's also similar, but for B and C, you'll have to refer back to the previous electricity equations. If you have any questions, make sure you go to the forums. And you guys have been doing really well with showing your work and your calculations, so keep up the good work, and you should be able to continue getting good grades on your homework. The lab goes back to specific heat capacities this week, so make sure you follow the directions in the lab as usual. This time there's no graphs or anything, but use the Excel that's given and make sure you provide all the units on your table data. The discussion this week, I believe you have to write 3 paragraphs. It's kind of like a little report on an article that you find online. So, and as usual, make sure you respond to 2 other students. Keep up the good work in the forums. Continue to help everybody. It definitely does help to try to help someone else through a problem to help you better understand it yourself. So if you're having any problems, make sure you go to the Cyber Cafe, and hope you guys have a good week. Thanks.